Ixia, a leader in performance analysis solutions, presents the IxNetwork video tutorial series. IxNetwork is Ixia's flagship software application for testing the network infrastructure, including all devices like routers, switches, network access controllers, broadband access, carrier Ethernet, and data center Ethernet. It's used by professionals around the world, including development and system test engineers, network design and support engineers, and even marketing and sales to demonstrate product capabilities and performance. This video tutorial is brought to you by the IxNetwork product management team.
Hello and welcome to this IxNetwork video tutorial on the BGP route import feature. In Chapter 1, we're going to start by covering the motivation and common use cases for this capability. Next, in Chapter 2, I'll show you how to take a BGP route table that was captured from a production router using a CLI command and then import it into IxNetwork to be used for testing. Then in Chapter 3, we'll take a look at how to save and export learned routes from a BGP peer using IxNetwork. Then once saved, they can be imported into IxNetwork to advertise. Last, in Chapter 4, I'll demonstrate how to use Traffic Wizard to integrate and analyze traffic utilizing the imported routes. Looking at the motivation and use cases for this feature, first, network equipment manufacturers need to characterize how their routers will behave in real world when connecting to large production networks. For example, do they have enough memory and CPU to handle the route tables at internet scale? Also, they need the ability to emulate live internet routing table without actually connecting to a production router, which can be risky connecting a live router to a lab. Also, most test tools today can easily emulate route capacity even greater than the current internet BGP routing table. However, the emulated subnet distribution and BGP attributes are considered non-realistic since they often have contiguous route blocks. Also, service providers want to perform BGP policy testing and prefer to, with realistic routes which are more random, have more variation in the attributes like the AS path and local preference. And they are modifying these to actually make routing decisions. In addition to emulating real-world internet routes, customers also want to validate how the DUT will install a large amount of routes, like 200,000 plus, by sending packets to every single source route. Lastly, one of the values of a test product is that it's repeatable. Using IxNetwork instead of a real dynamic routing table from a live router is a controlled environment. You don't have routes flapping and routing information changing on the fly during a test. Here in the IxNetwork application, I have 2 ports reserved. To reserve ports, click on the Add Ports button on the toolbar. I've also renamed them for ease of use purposes. For example, I'm using Load Module 1, port 13, and Load Module 1, port 14, and I've appended BGP-1 and BGP-2. For demonstration purposes, I'll be showing this in a back-to-back demo on 2 Ixia ports. Next, I'll show you one of the 2 ways to import a BGP route table. To do this, you must have already captured the route table offline. BGP routes can be imported directly from Cisco CLI using Show BGP output file. Today, the Cisco CLI output is the only format we support. For route output files from other vendors, Ixia has an intermediate file specified in the comma-separated .csv format. Users can easily write a conversion script to turn a non-Cisco format into the Ixia intermediate file format. The route import file will allow both .txt and .csv file imports. To show you an example, here's an internet route table captured from a production router using the Show BGP command. And as a result, all of these routes are part of this table. This table here in this format, coming from a Cisco router, can be directly imported. So one of the first ways to import a BGP route table is to go to Protocols and launch the Protocol Wizard. In the Protocol Wizard, select BGP and choose Run Wizard. Now, I'm going to run this on one port. Normally, when you do an import, you typically will run it from one single port, but you may also use it across multiple ports. Now I need to select Next here. So here in this configuration dialog, under Configuration Options, we have a new selection called Import from File. To import routes, click that button. Then for the file name, click on the selector. In this case, I have the BGP route table on my desktop. So I open the file. And then next, in the lower box, we have the peer topology. So we can tell the wizard how many peers we want to build per port. To keep it simple here, I'm going to do one peer on this port. And we can configure these to be connected BGP peers, meaning basically on the same subnet or direct connected, or over unconnected interfaces. If you choose unconnected, the wizard will also prompt you for the IGP using OSPF or ISIS, and we'll need to configure and build that protocol as well to communicate the routing information. So after selecting, in this case I'm going to stay with connected. So just choose Next. This particular default addressing is okay for my test because I have the other port in the test already configured. That's going to be acting as the DUT. On screen 4, we have a couple different options here in terms of the configured routes imported from file. So we can have an option to configure the AS path as an AS set. We have an option to internal peer set med value. We have the option to advertise the best route only. In the Cisco route table, for example, we may have multiple routes to multiple paths to different networks. However, one is deemed as the best route based on the metrics. So typically only the best routes get built and actually built into the forwarding table. In this case, I'm going to choose advertise the best route only. And then what we do internally is we take the number of routes and we assign them to an opaque route range. It's our own internal terminology. But in that range, we basically can take a routing table as big as 350,000 routes, but we can't put them all in a single range. We have to break it up. So the route ranges can be as low as 1,000 routes or as high as, I believe, 100,000 routes. In this case, our default is 80,000. In this particular route table, it's truncated, so I have, I think, a little under 200 routes that I'm going to be working with. So they will all go into a single route range here. Next is the route distribution type. The route distribution, if you select, you have accumulated or distributed. If you choose accumulated, the whole route table will be advertised per each peer configured. If you choose distributed, it will evenly distribute that route table over the peers configured. Once again, I only have one peer and one port here, so all the routes built will be advertised only over that one port. So I choose Next. And then in this case, I'm going to select Generate and Append because I already do have some BGP configuration on the other port. And if I wanted, I could name this wizard and come back to it and rerun it if I need to. So I'll just call it BGP 2. So say Finish. So I see here the BGP wizard has parsed and processed the BGP route table in the .txt format, and there were 195 routes that are imported, and I have a message here saying the route import is complete, but I do need to apply the routes for them to be active. So I'm going to say close and close again because we're done with the wizard. Now to see what we've built, first of all, just to show you under protocols and routing and switching, let's first take a look at the protocol interface, and I can see that here's where my back-to-back setup makes more sense, is I'm using 20.20.20.2 on port 1 and 20.20.20.1 on port 2. And you can see here my port link is good. I can tell that my ARP has been resolved. So as I come over to the BGP view, as I click on the BGP folder, I first have the diagram information. I click on ports, I can see I have a single peer configured on each port. I had already pre-configured the peer on port 2, and the wizard configured the peer on port 1 for me. As I click on the IPv4 peers, I can confirm my address information, 20.20.20.2, is connected to 20.20.20.1. So you can see here we are direct connected, and in this case I don't need an IGP configured to convey routing information, because BGP can establish adjacencies over more than one hop. Next is look at the route range, and here in the route range I can see I have one route range configured on my BGP2, my second port. So that's going to be advertised towards the first port, but we are advertising the imported routes from our first port. Next I click on the opaque route range tab, and as you see here I have one opaque route range, and within this range the range is enabled, and I have 195 routes that I've imported that now can be advertised from this port, and the status is need to apply. So it's really a two-step process here. One is you import the routes, next is you apply the routes. So I can click on this line item or click on this field right here and click apply. We then process that file and push it down to our port CPU so that we can advertise those routes. So that's all we really need to look at this point. We can start our BGP peers. To start the peers, I'm going to right click on the BGP folder and say Start Protocols. Here I can see I've gone from starting to running. The protocols are running. To view the real-time status, I can right click on that peer and say Open the BGP statistics. Here in the BGP stats on our port 1 here, I can see my state is established. I've advertised 195 routes and I've received one route. So you can click this button also to refresh that, but it should be a stable state here. So I'm going to close that view. Over here on port 2, as I right click on that, I can say Open the BGP statistics. This peer also says he's established, and I've received 195 routes and advertised one route. So you can see here that we've accomplished our goal of importing and advertising those routes. But an important component of advertising those routes is validating those routes. So to validate those routes, or actually see the routes we've advertised, there's two ways to look at this. One is, as we look back here, we can double click on the apply here, and actually we have a read-only view of the route table that we've imported. So in this view you can't edit it. If you wanted to edit it, you would have to edit it in the .txt file, or we do support a .csv file. This here is a read-only view, and you can see the network information, the next hop, the metric, local preference. So using this particular method, we do retain all of the BGP route attribute information. So even though this is read-only, the table could have been edited in the .txt file before importing. So we'll go ahead and close that view. Another way to look at the routes is, this is on the sending side. On the receive side, if we go to the IPv4 tab and go to all, as we scroll across here, we can see these checkboxes for filter IPv4 unicast. And so on port 2, I'm going to enable filtering on IPv4 unicast. This will actually allow me to capture those routes on the inbound side. And so for now I'm going to right click and stop the protocol, and right click and start the protocol. And by starting the protocol, I can see I'm running here. As I expand my peer view on port 2, I can click on learned routes and refresh the view here, and I can see I have received all of those routes, the 195 routes. So you can see you can validate it here once you've imported them from the read-only view on the transmit side, and then I have basically the read-only view on the receive side, and here I can validate all the routes. And if I was doing something, if my DUT was doing a policy filter or potentially blocking certain routes, like for example here at the bottom of the table I see 10 network IP addresses, and the 10 network is a private addressing, And so if I was advertising these to an eBGP peer, the eBGP peer would have a policy that filters out the private, also known as Martian routes. So these 10 network addresses would be filtered out, and I could use this particular routing table to actually test that and validate the 10 network was not advertised over that eBGP peer. So this completes the first method of route import, and next we'll move on to the second. For the second method, let's first go to my IPv4 peers here, and I'm going to basically get rid of my current routing table. So let me right-click on my BGP folder and stop the protocol. And then on my BGP router here on port 1, under the opaque route range, I'm going to highlight that, and I'm just going to click on the delete key on my keyboard, and I can remove that route block. So now I'm back to having my IPv4 peer configured with no routing information built in and configured. So as I mentioned before, one of the methods that I first showed you was importing routes using the wizard, and in that case I used a Cisco file with in the .txt format, which IxNetwork can parse and process and import. The other method is via CSV. So I'm going to open an example CSV file. Okay, let me re-window here. So in this example CSV file, this happens to be the same route range, route table we were just working with, but basically I can look through it here and I have a route table in a format that we are able to import. So essentially is a standard format of the route, the next hop, and the attribute information. So in this case I don't have specific attribute information in here. I'll explain why later, but I have this route table in .csv format. So from other vendor routers, I can take and export and convert the routing information into a CSV file. Then using that CSV file, I can import it. We already showed you the method using the BGP wizard. Next is directly under a BGP configuration. In this case, I'm going to click on this particular peer address. You can go to the peer, and before you've probably used this tab here to add route ranges manually. Well, there's this new opaque route range tab here as well, and you'll see the plus button here, or clicking on this plus button will launch the new BGP route import wizard. By doing that, it pops up this screen here, and it's very similar to what you saw before. So for example, I'm going to click on this button and choose my file. In this case, instead of doing the Cisco generated file in .txt format, I'm going to choose the comma delimited format, the CSV file, and I'm going to click on this BGP learned route and select open. As I did before, I'm going to choose the option to advertise best route only. Typically when you get a routing table from a internet router, in the example the Cisco config, you can have multiple paths to the same network. In the Cisco CLI, you will have an indication of the best route, meaning the one that gets used in the forwarding table. In this case, I'm going to have that checkbox enabled. However, I believe that this particular CSV only has a single path for each network. I click Next, and I just say Generate and Append, because I have configuration that already exists. I don't want to overwrite it. So I say Finish. And once again, you see the result, and in this result dialog here, I can see the file that was imported and the number of routes that were valid. So once again, it's 195 routes, and we can go up to 350,000 routes, so well beyond the current internet routing table. And once again, I also see the message that says route import complete, but need to apply the routes. So I close that dialog. And here I am, and once again I can double click on this guy, and when I double click on that, it will bring up the read-only view. So by double clicking on that, it brings up my read-only view, and I can look in and validate this information. I could have edited or modified the metric and preference information before importing, but once I have imported it, this is read-only once again. So now I just click on this and I click apply. By applying, we process those down into our port CPU so we can advertise them. As I click on the folder, I right click and I click on the start protocols. So I see my protocols are running. Now on the second peer here, I can right click and say open BGP statistics, and I can see that the peer is established, and on the receive port I have received those 195 routes. So those are the two methods for importing. Once again, one, you can run the BGP wizard and choose to import routes instead of building emulated topology, or secondly, you can go on the peer itself, and in the peer itself you can select the route range. In this case, all the routes are applied and advertised to that specific peer. In the use case of choosing the wizard, the BGP wizard, the routes imported can be distributed as an aggregate or distributed across all the peers and ports configured. So that's the main difference. So in Chapter 3, we're going to take a look at how to save and export learned routes from a BGP peer using IxNetwork. So to start with, we first go to my BGP peer, and in this case I'm going to go to the peer on port 2 because on port 2 I have enabled learned routes, and as I showed you previously, we have this view where we can actually show you the routes learned. Once again, to see the learned routes, you have to make sure that under the BGP tab and under all, as you scroll to the right, you have to make sure that the filter by IPv4 unicast is enabled. Our current capability for importing routes as well as saving out learned routes is limited to the IPv4 family of routes currently. So now that I have that enabled and my learned routes dialog is getting populated, I can see here, in fact I'll click refresh, and I'm learning about 195 routes. So there's a new capability here with the export button. By clicking export, we can save this information out into a CSV format. So in this case, I've already saved this out on my desktop and called it BGP learned routes. So this is actually quite scalable. When we're paired with a device under test, and that device under test is advertising us routes via BGP, we can save and capture up to around 500,000 routes. So the good news, it's very scalable from a route standpoint. The only downside of importing routes this way is that we currently disregard or basically omit the attributes on the receive side when we capture the routes. So if it's important to get and capture attributes, then we would use method 1, where you capture from CLI or convert to CSV file format. If you do it via this way and you capture via learned routes and you export, I want to open up that CSV file again just to show you. Essentially, we capture the type of route. In this case, it's an internal route, and then the actual route itself, the next hop. In this case, the next hop is the other IXIA port, but normally the next hop would be the DUT itself that we're learning against. And then you have your attribute information, and in this case the attribute information is basically all zeroed out. So if you wanted to, you could edit the CSV, you could modify things like the metric and the AS path and the multi-exit discriminator, and you could modify that information and then re-import that. So in Chapter 2 I did show the two ways to actually import this file. One is via the BGP wizard and 2 is via the BGP peer. So this essentially concludes chapter number 3, which is the new feature to export out learned routes. Then once those are exported in CSV, we can import those routes and then re-advertise them. For the final chapter, chapter 4, I'm going to demonstrate how to use the traffic wizard to generate and analyze traffic using the imported routes. So to generate traffic, we click on the traffic view in the test configuration list here. Now I have my choice of generating or using the basic traffic wizard, the advanced traffic wizard, or quick flow groups. To use and build traffic associated with routes, like to and from advertised routes, I would normally choose the basic or advanced wizard. I'm going to choose the advanced wizard because the advanced wizard has a feature called the preview, and I actually want to see the traffic information that I've built, so I'm going to choose the advanced wizard. So once the advanced wizard is launched, I need to select the type of traffic, and my encapsulation in this case is IPv4. Once we select that, the traffic wizard will filter for all the IPv4 endpoints, including the BGP routes. So just by simply right-clicking and saying expand all on the source and destination, I can quickly pick and choose to send traffic to and from my routes. So in this case, to test the forwarding path on a router, you typically want to send traffic to each of the routes advertised. So I'm going to send traffic from my second port. I'm just going to source it from the single route range that exists on my second port here. So that's my source. Now for the destination, under my first port here, I can see it's a BGP-1. I want to send traffic to all of the opaque route range traffic. So in this case, it's 195 routes. So I can see my source is on port 2, my destination is on port 1, and I will be building traffic to the entire opaque route range, in this case, 195 unique destination routes. So I just click and build that endpoint pair. In this case, I only need to build one endpoint pair. I'm going to do unidirectional traffic. So I select next. The advanced wizard has a lot of capabilities, including the capability to edit the packet content. I don't need to edit the content or modify the payload, so I'm going to click next. In this case, I'm not going to be building flow groups, so I can skip this as well. I'll go with the default frame setup, which is a default of 64-byte packets. I can choose the default rate. In this case, I'm just going to transmit at 10% wire rate by default. Now, tracking is important, especially with routing. So this track by is actually populated based on what you've built. So in this case, we have Ethernet and IPv4 traffic. A lot of times when you're doing routing testing, you may want to track on the destination address. Now, if you're doing an extremely large routing table like 350,000 routes, you may not want to do that because it's a lot of tracking, and depending on the utilization, and you can determine the utilization down here by the number of bits used. But in this case, I only have 200 or under 200 routes. I can easily track by the destination address, and I don't need egress tracking, so I select next. And the preview is actually quite important for me here because I want to view and validate that traffic is going to each and every one of the routes from my BGP routes being advertised to me. So I click on the View Flow Groups and Packets. So it processes that information and builds my preview. When I click on my traffic item 1, which contains one flow group, I can see that in the bottom here of my preview, I have my source and destination MAC that's resolved via ARP, and then I have my source address, which is that source BGP route range, and then here's my destination address list. So I can see there's 195 unique ones, and as I scroll through, I can validate that sure enough we're building traffic to every single route from BGP. So this is really quite important because when you're doing protocol testing, in conjunction with protocol testing and exercising the control plane, you want to exercise the data plane as well, especially when you're getting into route flapping. When you withdraw routes, you want to make sure that the traffic is no longer being forwarded since the route is withdrawn. So I click Finish, and the advanced wizard will go ahead and process that and build all of my traffic. So once again, I've built all of those flows into one single traffic item. I can see it right here. And now I simply click on the apply. I apply that traffic to the hardware. Once the traffic is applied, I'm going to switch over to the statistics view. And once I'm in the statistics view, I'm going to start my traffic. And once traffic is started, I want to click on the traffic item stat level view. The traffic item stat level view gives me summary information. So very quickly I can see my transmit and receive frames, and if I have any loss at that point. Now the traffic item once again is a summary level. Now since I did enable tracking per destination IP, I can right click anywhere on this line on the traffic item and do a drill down per IPv4 address, and I'm just going to re-window here a little bit, and I can see I have statistics for traffic to every single route that I have. So I have 4 pages of stats I can page through, and I can look at traffic for every single route and validate that I don't have any loss across all my routes. So if I was testing in a more complicated environment with multiple paths through the network and different paths had different performance, I could come in here and validate that, and I could determine which paths had the best performance. If there was any kind of routing, rerouting going on, or load balancing or failover, I could come in and measure my traffic performance per IP destination address. So this is a new and powerful feature introduced in IxNetwork 540 that incorporates the summary level view at the traffic item with the right click and drill down into your track by options. So this is paired very well with the BGP route import, because once again you want to exercise the control plane and data plane at the same time. So this concludes the IxNetwork video tutorial on the BGP route import. Thank you for your time.
For more information on IxNetwork, check out www.ixiacom.com. Thank you for your time and interest from the IxNetwork Product Management Team.